video covers section 3.3 in our calculus book. We're talking about increasing or decreasing on an interval. We say a function is increasing or decreasing on an interval, and that interval is the x values. If f prime of x is greater than 0, or if and that's another way of saying the derivative is positive, the function is increasing on that interval. If f prime of x is less than 0, or if the derivative is negative, the function is decreasing on that interval. We increase to a maximum value, could be a relative max or an absolute max. We decrease to a minimum value. Same thing, it could be a relative minimum or an absolute minimum. If we look at this graph, we see the function is increasing up to this maximum value. The x values of that interval are negative infinity to negative 2.5, because anywhere we go to the left to negative infinity, the function is going to be increasing. The function is also increasing on this interval from negative 0.5 to 2. Again, we're looking at the x values. The function is decreasing from negative 2.5 to negative 0.5 on this x interval, and then the function is also decreasing from this maximum value at x equals 2. The function is decreasing on the whole interval to positive infinity. If we want the largest interval where the function is increasing, that's going to be negative infinity to negative 2.5. Obviously, that's a much bigger interval than this other interval up over here, which was from negative 2.5, which was from negative 0.5 to 2. Similarly, if we want the largest interval where a function is decreasing, that's going to be from 2 to infinity. Let's look at an algebraic example. So, our process is going to be to find the critical numbers and check what's happening in each interval. Our function is x cubed over 3 minus 4x. To find a critical number, I take the derivative. The derivative is 3x squared over 3 minus 4, which simplifies to x squared minus 4. If I set x squared minus 4 equal to 0, I can factor that into x minus 2, x plus 2. My two critical numbers are where x equals positive 2 and negative 2. I'm going to make a sign chart and see what's happening in each of those intervals. In other words, I'm going to just check and see if the derivative is positive or negative. I know the derivative is 0 at negative 2 and positive 2. Those were my critical numbers. I'm just going to pick a number in each x interval and see if the derivative is positive or negative. So again, my derivative is x squared minus 4. If I check negative 3, negative 3, the quantity squared, is 9. 9 minus 4, it is 5, I don't even care. All I care is that that's a positive number. So my derivative is positive, the function will be increasing. I'm going to check 0. 0 is the easiest number I can choose between negative 2 and positive 2. You don't have to choose 0. You can choose any number in this interval, but I'm trying to make my life a little simpler. So f prime of 0 is negative 4, which is negative. If I check a number greater than 2, I'm going to go ahead and try 3 again, because f prime of 3 is going to be the same as f prime of negative 3, positive 4. So I've got my function is increasing on the interval negative infinity to negative 2, union the interval 2 to infinity. My function is decreasing on this middle interval, which is negative 2 to positive 2. If I want to figure out if I have a maximum or a minimum at each critical number, I just think about what's going on. If the derivative is positive, I'm going up. The derivative is negative, I'm going down. I have a relative max at x equals negative 2. I haven't memorized anything, I'm just thinking about what's going on. Going up, going down. If I check at this second critical number, my derivative is negative. That means I'm going down, then I'm going up. So right here, we have a minimum. So I have a relative min at x equals positive 2. If I wanted to find the exact values, all I would have to do is substitute in negative 2 and positive 2 into my original function. And I have a graph to show what the graph of the function looks like. And I can see I have a maximum here at negative 2, a minimum at positive 2. My function is increasing from negative infinity to negative 2, decreasing from negative 2 to positive 2, and then increasing again. So the graph matches up with our information. I'm going to look at one last algebraic example. My function is x plus 1 over x, which I'm going to rewrite as x plus x to the negative 1. The derivative is 1 minus x to the negative 2, or 1 minus 1 over x squared. Since we can also have critical numbers where the function is undefined, I'm going to write this as a fraction with a common denominator. So my common denominator would be x squared, which makes my derivative x squared minus 1 over x squared. The two places where I have critical numbers are where the function is equal to 0, where x squared minus 1 equals 0. This is just like the last function. I could factor it and get my two critical numbers, Rx equals 1 and negative 1. I also have a potential critical number where the function, the derivative, is undefined, which is at x squared. If I set x squared equal to 0, I get x equals 0, so that's another critical number that I have to check. I'm going to go through the process just like I did last time. I've got my critical numbers. I'm going to check and see where the derivative is positive or negative or undefined. I know at negative 1 and at 1, the derivative is 0. I know at 0, the derivative is undefined. My derivative function is x squared minus 1 over x squared. Since x squared is always positive, I'm not going to worry about substituting into that to see if my derivative is positive or negative, because if I divide by a positive number, I still get, that does not change my answer. So I'm going to look at what happens just with x squared minus 1. I'm going to follow the same process like I did last time. If I look at f prime of negative 2, if I square negative 2, that's positive 4. 4 minus 1 is positive. Next, I'm going to pick a number between negative 1 and 0. I'm going to try 1/2. If I do f prime of, negative 1/2. If I do f prime of negative 1/2, I square negative 1/2, That's 1/4 minus 1. I don't care what the number is, I just care that it's negative. And because I've got a squared, I can think what happens if I substitute in positive 1/2. If I put a positive 1/2 here and square it, I'm still going to get a positive 1/4. So this interval will still be negative. I'm going to try 2. F prime of 2. 2 squared minus 1. 4 minus 1 is positive. So I've got my function. My function is increasing from negative infinity to negative 1, union 1 to infinity, because those are the two places where the derivative is positive. I'm not going to include this 0, so I'm going to write 2 intervals here because at 0 the function is undefined. My function is decreasing from negative 1/2 to 0, and 0, I'm sorry, from negative 1 to 0, and from 0 to 1. So decreasing negative 1 to 0, union 0 to 1. Again, if I want to find out if I have a max, a min, or neither at each point, I'm going to think about what's going on. The derivative is positive, the derivative is negative. This is a max. I go up, I go down. The derivative is negative, something happens, the derivative is negative. This is an either. Either we have an asymptote there, or the graph flattens out, or something else. If I look at my last critical number, the derivative is negative, so I'm going down. Then the derivative is positive, I'm going up. That's going to be a relative min.